Hello, this is Rick Powers coming to you from my home office for Introductory Statistics. Introduction to week 14. Just 2 weeks left. And yes, it's really important for me to make this video because this particular subject is one of the biggest things that happens in statistics. You see it all over the place, and it's a big deal. And so I wanted to make sure that you understood what was going on with what we're doing. Previously, we had always had situations where we would ask a question and we would only get one answer, like, do you support Joe Biden, yes or no? Or it could be something like, how many days did you take on vacation, or something like that. So it's either a yes or no answer, or it's a number, and then we would only ask one thing. Well, but one of the most powerful things in statistics is when we ask people more than one question. So we might ask them, for example, how much money do you spend on restaurants, and how much money do you spend on sports? And so we could find out, is there a connection between people who spend money on this thing versus that thing? Or we could say, how much time do you spend outdoors versus what's your cholesterol level? Something like that. So there's all kinds of different things. How many television shows do you watch versus how many hours do you study? Well, let's not get too personal. But things like that, where you're saying, what questions can we ask, and can we find relationships between different factors or different variables, different concepts, different measurements? So what I want to show you is what this does mean and what it doesn't mean. Okay, so I'm going to share my screen with you here so that you can see what's going on. And what I've decided to do is to use a data set that I found on the web, and it was done back in 1950. And what they did was they had a bunch of people, a couple hundred people, yeah, 200 people, and they measured their age in 1950, and then they measured their blood pressure. Now, you may know that blood pressure has two numbers. It has what's called the systolic and the diastolic. The systolic is the higher one, diastolic is the lower one. So they measured both of those. And then they measured their height, their weight, and their cholesterol. And then 12 years later, they went back to these same people and did those same measurements. They figured their height didn't change very much, but what their weight was and what their blood pressure was and what their cholesterol was. Now, there's all kinds of ways that we could examine this. For example, we could say if somebody lost weight over that 12-year period or gained weight, then how was that related to their blood pressure? Something like that. There's all kinds of possible questions, but what we're going to look at today is just what this looks like. How do we go about analyzing something like this? Now, what you're going to have on your homework, you will have certain situations where you can just click a button and it'll take all your data and put it into the SALT technology program, which is fine. But sometimes you won't. And so then you'll have to actually input the data yourself. So as you can see here in Excel, this is, a lot of people know how to use this and have used this. If you have some other way or some other software or some kind of calculator, graphing calculator, that's fine. But what I have here is that I have their age and their systolic blood pressure. And so the first thing I want to do is I want to graph this relationship. So what I'm going to do is I'm going to pick these two columns, and then I'm going to click where it says scatter. Now you might have something else where it says insert. Oh, this was the insert menu up here. not the file menu and not home, but the insert menu. And then you click on scatter. And you might have some other things like insert chart and then scatter. That's what we want. We want a scatter plot. So we click on that. And it gives us this particular graph. Now, when you look at this graph, what you can see is that it's scattered. Okay, there's a lot of scattering here. And this is almost always what happens. Unless you're doing something like in physics or chemistry or something like this, you're not going to have the dots on a straight line. This is a very important thing to understand. Pretty much most things in statistics are clouds. So this is a cloud you're looking at here. Now let's do the other one. Here we have the diastolic and the systolic. And what does that look like when we make a graph? Well, it looks different. Okay. So here are these two graphs. Now, we can certainly see that in this one, everything seems to be kind of scattered about. But here, it seems like there's a trend where if you have a higher diastolic, you will have a higher systolic. So that if one of those numbers is high, so is the other one. If one of the numbers is low, so would be the other one in comparison to other people. So this is a lot of what happens in statistics is we're looking for this kind of relationship, a trend relationship. Now here, it looks like it might follow more or less a line in between there that we could draw. And it would be a positive relationship because as one of them increases, the other one increases as well. If this line were pointing the other way, if it were pointing downwards, this would be a negative relationship. And then over here, this one, it looks like there's no relationship at all. They just are a bunch of cloudy points, just kind of scattered there. Okay, so then if we ask the question, how can we figure out what is going on here in terms of the relationship? I'm going to move this out of the way for right now. And we're going to talk about something called the correlation. So I'm going to hit an equal sign, C-O-R-R-E-L, and then a parenthesis, column B, comma, column C, parenthesis, boom. So here's the correlation between age and blood pressure. Oh, I'm sorry. I didn't want to do this one. I wanted to do weight. C V. This is what I wanted. I wanted weight. There we go. So now you can see it's even more of just a cloudy mess over here. So if we say, what's the relationship between a person's weight and their blood pressure? And it's like, well, it doesn't seem like there's much of one here. Whereas the relationship between the two numbers in blood pressure, there seems to be one. Well, here we have a correlation here, which is a number 0.1. Now, I have a lot of videos that I posted about what that means, but I wanted to show you here in Excel what that looks like. And so here I can also have a correlation between column E and column F. And then this number is larger, and so it shows the correlation is stronger. So again, you'll need to look at the videos to see how to interpret that. But then I also wanted you to know that if we want to know something about the line that would go through these points, then we can use the command slope, S-L-O-P-E. But here we have to do the second column and then the first one. We have to put in the y coordinates and then the x coordinates. And then we get the slope. And here the slope, and that would be for this one down here, or this one up here. This slope is hardly anything. There's no real effect. But in this one, again, I pick the y coordinates and then the x coordinates. And it does have a slope. So then if we go down to this one, we see that there is a relationship that we can tell between these variables. And it's positive. As the diastolic goes up, the systolic goes up. So there's where the slope is. Now, using Excel works, all right? And it especially works if you don't have the button that gives you the technology. You can put things into Excel, and you can find the slope, and you can also find the intercept. But I also wanted to show you what it looks like if we do use SALT. Okay, so here is SALT. And here we have weight and systolic blood pressure. As you can see, this line hardly goes up at all. There's not a real relationship here. It's just a bunch of cloudiness. And then you can also see that there's a p-value here, which comes out to be 0.15. So there's not evidence for a relationship. P-value is greater than alpha. There's not evidence for a relationship. And here you see the intercept and the slope. However, if we go with this, where we have the diastolic blood pressure and the systolic blood pressure, you see that there is a clear relationship here. And the p-value is pretty much 0. So the p-value is less than alpha. That tells us there is evidence of a linear relationship here. And we have the slope and the intercept. But I just want you to be very clear about this. When we say that we found a relationship, it's not true in the sense that most people think. The straight line is not the relationship. Clearly, the points do not actually fall on the line. The line is an estimate of the average of these numbers, but we don't actually know what's going to happen. We're supposed to know what to expect, right, with statistics, but most of the time, that straight line that we're talking about is not true. It does not tell us the relationship, because the relationship is the cloud. It is not the line. And of course, if you were to take the next level up in statistics, we'll talk a lot more about that. All right, so I'm hoping that this is going to give you a sufficient understanding of what we're doing here, that we're talking about relationships between two variables, and we have technology that can help you to figure out the numbers that you need to know. And at the same time, it doesn't tell us what's really happening. In order to know what's really happening, we have to look at the cloud. We cannot simply look at the line that goes in the middle of the cloud. All right, well, best wishes for this week. And this is our last topic, because next week is just going to be taking a test on this material. So yeah, best wishes for the rest of the term then, and hopefully for the rest of your educational experience.